Alright, guys, welcome to the session, and I hope all of you guys are doing good. So let's get started. So we are going to connect for uh, the sessions today, tomorrow, and day after. And in this particular session, we will be talking about the concept of exploratory data analysis. We'll spend time and we'll try to understand it. I'll be creating certain charts using Python. The agenda here is to understand how the chart is giving me the information, right? How to write the code in Python and all. We will have a proper sessions in future. So the agenda is not to understand the Python code. That is not the expectation. The expectation is that you should understand the chart and what that particular chart is giving me the information, right? That is the idea. So when we are working in any data projects, this is one of the important steps which we have to perform, and without this we will not able to get the understanding of data. Whenever you are working in any data projects, it is always advisable to understand the data first. And once you understand the data, after that, if you are working on the projects, you will be going to enjoy the entire project, right? That is what I always tell my learners. So now we will take one data set as well, which will be a bigger data set. And at the same time, we will be understanding some of the charts through that data set. So let's start with what is EDA? What is EDA? EDA is basically nothing but exploratory data analysis. In simple words, if I want to talk about EDA, EDA is like a detective work on a data set before you do anything serious with it, like modeling, predictions, or creating the reports, right? It's your chance to explore the data, understand what's inside, and catch problems early. So basically, the purpose of EDA is to understand your data set, and at the same time, if there is any problem with the data set, I will like to catch it as early as possible. Because our intention from the data is to come up with the insights, create some models out of that. Models can be a machine learning models where we are predicting something. We'll have a discussion about that later on. But as of now, as a layman, you can understand that based on certain details, I am trying to predict some other details. For example, let's say I want to predict how many marks I will get based on how many hours I'm studying, right? So that is your prediction and modeling concept. So as of now, these words are new to you. So that's why I'm just giving you the idea that when I want to do some predictions or I want to create a model, right? So in that case, EDA is one of the important steps as well. Plus report is nothing but as a data analyst. As a data analyst, when you are analyzing the data, then at that time also EDA is coming into picture. So that is one of the very important steps. And when we are talking about EDA, right, almost in your data projects, whether you are working as a data analyst, whether you are working in a machine learning engineer, or you are working as a data scientist, or you are working as an AI engineer, around 70 to 80% time is going on the data analysis, right? EDA. Rest of the steps are quick, very much straightforward, but understanding the data and getting the insights, finding the relevant important features, that is nothing but columns. So those things are important for us. We'll take one small data set, we'll understand also. But the idea is that if I want to analyze some data at that time, we have to be very much sure that what columns are important for me. As in, let's say I want to predict whether my customer will get loan or not, right? So if my customer will get loan or not, what all things are important? Is age important? Is gender important? Whether you are married or unmarried is important. Whether you are graduate or not graduate is important. or your credit score is important, right? So basically I want to find out, I want to analyze my data, and I have to find out that which features are important to predict whether my customer will get loan or not, right? So when we are doing some model building, at that time also we need to find out the relevant columns, which is very important because I cannot pass all the columns. It's all calculations and it takes time, right? So if I pass a lot of junk features which are not important as well, if you are passing that, then it's not going to make sense. It's going to be a time consuming process, because in real time we are not dealing with a smaller data, we are dealing with a huge amount of data. And if we are choosing some of the columns which are really not important for us, so in that case training the model will take a lot of time, and that is again one of the problems, right? So EDA is a very important aspect. As a layman, you just understand that when you are playing with the data, at that time EDA is very important, right? You have to analyze your data very much in a way that you should able to understand what's going on, right? So that's why it takes time, because as I mentioned, we are not dealing with a small data, we are dealing with a lots and lots of data. It can be more number of columns, it can be more number of rows. So overall data will be very huge. And if the data will be very huge, in that case, what will happen? It is going to take time for you to analyze, right? So that's the reason this is one of the very critical and important aspect. Now, some more understanding. So think of EDA like meeting a new person for the first time. You ask questions like, what's your name? What do you like? Are you talkative or quiet? Do you lie? You observe the behavior before deciding whether you trust them or want to work with them, right? Same goes with data as well. When you get the data, you have to ask questions from the data, right? What type of data you are, what all columns you have, which columns are important, right? So we have to ask a lot of questions on the data set so that we'll understand about the data. And once we'll understand about the data, then we'll start working on that data, right? So that is the idea. So the time which it takes to understand a person, almost the same time it takes for understanding the data as well, right? It's very important because your entire predictions, your entire business is depend on what type of analysis you are doing. That's why data analyst job is one of the very critical jobs, right? You're going to do a lot of analysis and you have to give a lot of insights to the business. Similarly, in EDA, you meet the data, you ask it, is it clean or not? Is it having some missing values or not? Is it telling the truth or not? Is it balanced or biased, right? Balanced or biased is something like, for example, let's say whether my customer will get loan or not. And in my data set, I can see that all the males are getting the loan, but all the females are not getting the loan. So that type of data, I can say it's a bit of a biased data, right? Where you can see that males are getting the loan, females are not getting the loan, that straight away there's some problem, right? So that type of data is like more of a biased, which is like focusing on one of the features and not the other, right? So that is the thing which we should be aware of. So a lot of analysis we have to do. By just understanding these two slides, you must have understood that a lot of things we have to do when we get the data, right? So it's very important step. Now, why EDA is important, right? Again, we already had a brief discussion, but here you can see you can't fix what you don't see. Suppose let's say something is wrong in my retail store, but if I am not able to find that out from my analysis, then I will not able to fix that, right? Let's say, for example, in the north region, my sales is not happening much, but from my data set, I am not able to find that out, right? I'm not doing a proper analysis that is helping me understand that there is a problem with the north region. And if I am not doing that, obviously it is impact my business. So that is what it is mentioned. You can't fix what you don't see. So if you are not analyzing the data properly, or if you're not analyzing the data at all, then you will not able to get what's the problem going. That's why it is very critical aspect to analyze your data. Second is a bad data set, bad prediction, and bad decisions. So for example, bad as in what? Let's say in my columns, there are a lot of null values, right? For example, there is a age column. In the age column, a lot of null values are there. Null value is nothing but where there is no entry. Let's say I have 10 customers information. Out of 10 customers information, 7 customer information, the age is null. That means that particular 7 customers did not pass their age while submitting the form or something. Now, if you are using age column for analysis, it's not going to make any sense because out of 10 records, only 3 records are there. What will you be able to analyze? If you're still taking that into consideration, that means it's not going to be a good data for you because you are taking a column where you have a lot of missing values, a lot of null values, right? So as such, that column is not really important. Yes, if there are null values, but not that in number. For example, here I told you the example that we have 10 records, 7 are nulls. That means 70% records are nulls. But when we have few nulls, around 20 to 25% nulls, then we can manipulate the data. So there we will modify some data, right? So that is again one part of EDA only, which we'll see in some time. So basically the idea is that when you are having a junk as in any random wrong information or null information. So whenever you are having a junk, if you're passing the junk to the machine will also going to give you the junk only, right? So that is what it is saying, a bad data set, bad predictions and bad decisions. Obviously, if you're getting some wrong predictions, then your actions will also be on the wrong side. And that is going to impact your this thing, right? Your overall business. So it's again very critical that you should be passing the correct values. Third is it saves you from embarrassing mistakes later, like drawing wrong conclusions, right? Suppose you did some wrong analysis and based on that, you went ahead and you basically took some decision. But as your analysis is wrong, the decision which you have taken is also wrong. And because of that, let's say we had a big loss in the business. So that means it's an embarrassing situation for you. And that is again one of the problems, right? One of the challenges which you can see. So it is very important that you understand the data very well. And once you understand the data very well, then only if you are taking some actions, that will make a lot of sense. But if you're not doing that, then obviously there is a problem, right? So that is why EDA is important. Now there are different types of EDAs are there. One is your univariate analysis, right? It's broken down into 4 different phases. First one is univariate analysis. Now, as the name suggests, univariate, uni means one, right? One variable analysis. So the idea is that if I want to analyze only one variable, for example, let's say in my data set, I have a lot of columns. Age is there, gender is there, height is there, weight is there, right? Salary is there. So a lot of columns are there in my data set. Now, I only want to analyze what is the age of my this thing, right? Data set. What is the age of, let's say it's a customer data. So what is the age of my customers, right? So I'm only analyzing one column, that is the age column. And once we are analyzing only one column, that is the age column, it's a univariate analysis. Age is a number, right? Age can be 20 years, 21 years, 40 years, 41 years, and so on. So the idea is that either you are analyzing one column, that column can be a numerical column, or that column can be a categorical column as well. For example, let's say I want to analyze gender. In this class, I want to find out how many males and females are there. So I'm counting males and females, right? So which column are you using? I'm using the gender column. So am I using any other column? The answer is no. So I am using only gender column and finding the count of it. How many males are there? How many females are there? So that is my univariate analysis where I am analyzing only one variable. That one variable can be a single numerical variable or that one variable can be a single categorical variable. For numerical variable, as I mentioned, age, I want to see how my learners are distributed based on the age. And second is, let's say, gender. I want to find out how many males are there and how many females are there, right? So that is your univariate analysis. Let's read this PPT as well. Studying one column at a time. You ask what are the values in this column. That means, for example, age, right? What are the values in the age? How the data is distributed? Majority of the learners are at the lower age. Majority of the learners are at the middle age, or majority of the learners are at the higher age. So we can get that type of information. Are they numbers or categories, right? I told you that it can be a numerical column, it can be a categorical column. What's the average, minimum and maximum value? This average, minimum and maximum value is applicable for the numerical column. For categorical column, it will not make any sense. For example, we have a categorical column called gender. Now, what is the minimum of gender column? I cannot say anything. What is the maximum of gender column? I cannot give any answer. What is the average of gender column? I cannot do male plus female divided by 2, right? It's not going to make any sense. So average, minimum, maximum normally holds true for your numerical column. Are there any outliers or weird values, right? If you remember in the mean class, mean median mode class, we saw the bell curves. And at that time, I introduced that concept. So this was the curve, this was the curve, and this was the curve, right? So this was a right skewed where the outliers is in the right side. This was the left skewed where outlier is in the left side. The values which are rare in number, right? So that is my outliers. So suppose let's say I'm creating a plot for age. This is my age plot, right? So now I see that, okay, there are some outliers at the higher side. Majority of my customers are at this age group, but there are few customers which are falling at the higher side as well. So that is an outlier. So again, by creating the plots, I will get the understanding, right? So are there any outliers or weird values? Can be again captured nicely. Example, the column is age, as I mentioned multiple times. Check average age, most common age range, etc. The plots which we are normally using is histogram, box plot, and count plot. Right? I'll show you these plots in some time. So when we are using only one and only one variable, that is known as my univariate analysis. Now let's say I am analyzing two variable at a time, right? I am analyzing two variable at a time. Now when I am analyzing two variable at a time, it is gonna be a bivariate analysis, right? Bi means two. So I'm studying two variables. For example, let's say I have the gender column, that is one column, and I have the sales column, that is the second column, right? Now I want to know what is the sales by gender. That means what is the sales for male, what is the sales for female. Now here I am using two columns. One is the gender column and second is the sales column. So as I am using two column, it is considered to be the bivariate analysis. Just give me a second, guys. Are you guys able to see my screen? Okay. So the idea is basically bivariate analysis. Again, you can have of three types. One is you are analyzing a categorical column and a numerical column. For example, I have the gender column, I have the gender column, and I have the sales column. So I want to find out what is the sales by gender. What is the sales by state, right? What is the sales by city? What is the sales by category? What is the profit by gender, right? What is the profit by state, and so on and so forth. So when we are using two variables, it's a bivariate analysis. It can be categorical and numerical, gender and sales. It can be categorical and categorical. For example, region and gender. Now, what type of information will I get from the two categorical column? I have the region column and I have the gender column. What information can I get from that? The information I can get from here is that in every region, how many males and how many females are there, right? I can just count it, right? Count is not a feature. Count is not coming from your source. Count is just I'm counting the records. So when we are having a categorical and a categorical, the information which I am going to get is count. That means in the north region, how many females are there? How many males are there? In the south region, how many males are there? Females are there, and so on, so forth. Right. So when we are having a categorical and categorical, in that case, we have just count as an option. Think of any feature. For example, I have the state column and I have the product column. What information can you get? The information I can get is for every state, what is the sale, what is the count of that product which sold, right? Okay, for example, in Haryana, I have the product as TV. In Haryana, 15 TV got sold. In Haryana, fridge, 10 fridge got sold, and so on, so forth, right? So basically, I'm only getting the count here because I don't have any other numerical column. The only numerical column which I can get is count, which is not part of your data. It just we are counting it, right? Your data is something like this. For example, region, your product. This is your data set. Let's say north region, north region, north region, south region, south region, west region. Product is TV, TV, fridge, 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 washing machine. Now, what information can I get? The information which I can get is in north region, 2 TV sold. In north region, 1 fridge sold. In south region, 2 fridge sold. And in the west region, 1 washing machine sold. This is the information I can get from these two columns, right? And I'm only using two columns. That is why it is a bivariate analysis. So how does one column affect another, right? That is what I can see from here. That means in the north region, is TV having more sales? How your north region is affecting your product column. So that type of information we can get from here. Do they move together, right? This I'll talk about in some time. Does one group score more than other, right? So that type of information we can get it. So what I told till now, it can be categorical and numerical, or it can be categorical and categorical. These are the two things I already explained. Third can be, it can be numerical and numerical. For example, I have my house. I want to know the house price. Is it dependent on the area of my house? So as and when my area is increasing, you can see this chart coming in. As and when the area is increasing, my house price is increasing as well. This one. Do they move together? That means when one is increasing, is other is increasing as well? The answer is yes. Or second could be, my house price is what I want to predict based on the distance from the city. If the distance from the city is increasing, my house price is decreasing, right? So this is also moving together only, but here it is in the opposite direction. When one is increasing, other is decreasing. Here also it is moving, but here what is happening? When one is increasing, other is also increasing, right? Same goes with, let's say I gave an exam and I want to know the score of my exam based on how many hours I studied. So more you study, more the marks you will get, right? Let's say this is the pattern. So I can say there is a relationship between the hours study and the score. And this type of relationship is known as correlation. That means I can say that hours study is having a correlation with the score. When our study is increasing, my score is increasing as well. It can be so my correlation value can be of three types. It can be -1 or more towards -1, or it can be 0, or it can be +1. The maximum value of correlation is -1 to +1. How it gets calculated, all those things we will be discussing in this entire 3 sessions. But the idea is that when it is going upward, right? When one is increasing, other is also increasing, your correlation value will be more towards +1. But if you see the previous example in the house price, right? So when my area of the house is increasing, my house price is also increasing. In that case, my correlation will be more towards +1. When my distance from the city is increasing, my house price is decreasing. So here my correlation is more towards -1, right? It should not be 100% +1 or -1. It can be around +1, -1 until unless it's purely correlated, right? Which normally in the industry you don't see that. But the idea is that once one feature is increasing, other is increasing, the correlation value will be more towards +1. It can be 1 also, but very rare chance. Same way, when this is increasing, the distance from the city, my house price is decreasing. So in that case, my correlation will be in a negative side. And again, it can be -1 or more close towards the negative, right? So we'll talk about more correlation in the future sessions, maybe tomorrow or day after, right? So here you can see that we have various examples of two variables analysis. One is hours versus marks, how many hours you are studying, and based on that, how many marks you got. Second is do more study hours, better marks, right? That type of information we are getting from here. Gender versus purchase. Do men and women buy differently? Right. So I'm analyzing two this thing. One is gender and second is purchase. Right. So based on the gender, do we have any other purchasing behavior, something like that? The plots we normally use is a scatter plot, bar chart, and box plot. Right. We'll see that plots in some time. But this is my bivariate analysis. Right. Bivariate analysis is nothing but when we are having two columns, it can be categorical and categorical, or it can be categorical and numerical, or it can be numerical and numerical. Till this point, are you guys clear, all of you? Any doubts you have, let me know, right? I don't want any doubts in your brains. So any doubts, let me know, I'll repeat it. Because these are the stepping stone and these are the foundation which you are talking about. So anything which you are not clear, ask multiple times, I will respond. You should be very much thorough. All right, so let's proceed then. Where it is used, we'll come to that. We'll take one data set, we'll understand. Okay. As of now, just try to understand what we are doing. I'll take one data and I'll let you know. But what is bivariate, you are understanding, right, Jay? No. Multivariate. Now, multivariate means what? As the name suggests, right? Multivariate. That means three or more than three. Right? Two already we discussed. Bivariate. Multivariate is nothing but three or more than three variables. When I am analyzing three or more than three variables, in that case, it is gonna be multivariate analysis. So here you can see that studying three or more columns together. For example, how do multiple factors combine and affect the outcome? Can you find groups or patterns? For example, let's say my marks, how my marks will impact based on the hours I study, based on the attendance of my class, and based on how many hours I am sleeping. So now what I'm trying to do is I'm trying to find the marks, how much marks I may get based on these features. And we have more features here. We have the study hours, we have the attendance, we have the sleep. Now, multivariate can also be again of different types. It can be categorical, 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 or more categoricals because it's three and more than three, right? So all are categoricals. Or it can be categorical, numerical, 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 like that. It can be categorical, numerical, categorical, sorry, categorical, numerical, 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 or it can be categorical, 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 and numerical, right? It can be numerical, 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 all numerical. So it can be all categorical, mix of categorical, numerical, mix of categorical, numerical, where more numerical is there, here more categorical is there, and all numericals. It's all combination because it's three or more than three columns. Normally, we don't go with more number of columns because just try to understand, right? When you are having a huge amount of data and you are trying to analyze multiple columns at once, it will be very overwhelming for you guys, right? When you are seeing a lot of data and you are seeing that a lot of information is coming in, processing as a human brain will be a bit of a challenging task. So normally we prefer to analyze three or maximum four variables, or at the worst five variables at a time, right? We don't analyze more than five variables. If you want to analyze and there are a lot of variables, you break it. Analyze five variables first, then analyze another five variables, then analyze another five variables, and so on, so forth, right? So for example, let's say you are having hundreds of columns. Let's say I want to predict whether my customer will purchase the product or not. And I have a lot of columns. Age is there, gender is there, education is there, past job is there, height is there, whatever. Various different columns are there. So I want to analyze that, right? And if I want to analyze that, I will be breaking into chunks and I will start analyzing that, right? So that is my multivariate analysis. It can be, as I mentioned, three or more than three variables. It can be all categorical. It can be mix of categorical and numerical. Sometimes categoricals are more, numericals are less. Sometimes numericals are more and categoricals are less. And the last is numericals, numericals, and all numericals, right? So that is your third type of analysis, which again we can do, and we'll see that basically on the data set also. Last is treating your data as well. Whenever you are working with the data, there can be a chance that you are getting very raw data, right? And raw data as in what? Raw data as in uh, it may have certain missing values. It may have certain, what do you say? Uh, Outliers, right, in my data set. So these are the things which we have to fix. Just take an example, right? Missing value, I already gave you the example that if I'm passing a lot of junk, my outcome will be junk as well. So we may have to fix that. If there are more number of records, then obviously I cannot fix it. But if there are less number of records, I can fix that. For example, let's say there are 1,000 rows. Out of 1,000 rows, let's say 100 rows are having missing value. So somehow I can fix that, right? Somehow I can fix that. But let's say out of 1,000 rows, I have 900 rows are missing values. Then as such, that column is not making any sense for analyzing it, right? So in that case, I may not be using that for further analysis. But that will be a discussion which you have to do with the business. And then you have to decide whether we should go with that or not. Second is outlier. Just take an example of insurance company, right? I am, let's say, running an insurance company and I have a lot of customers starting from the age of 20 years to, let's say, 60 years. So majority of my customers are at this age group, around 20 to 60. But there are few customers who are at the age of 90 years, right? They are also my customers, but their age is higher. And I am running an insurance business. I am planning to come up with a new product, which will give me more sales. Now, in that case, these outliers which I have, which are like around 90 years and above, we are very much sure that they will not purchase any insurance now, right? Because they are at the end of their lives. So why will they purchase the insurance at this point of time? Until and unless they want some policies for their grandsons and all those things. So that is a different case altogether. But the chances of purchasing them the new insurance will be a very rare, right? They may not purchase that because at the higher age they may not want that. So in that case, those are outliers for me, right? Those are like as such, they are customers for me, but as such, I cannot generate some revenue from there, right? So when I want to come up with a new product, I will be removing those outliers from my analysis. Then I will start analyzing which type of product I should come up with, right? Then I will be only focusing on the 20 to 60 years of age, and based on that, I will be coming up with the product. Because those outliers are of no use, I will remove them and then I can go ahead and I will analyze and come up with the decisions, right? So outliers in some scenarios you may have to remove from the data for doing some further analysis. Sometimes business may say that they want outliers in the data set and they want to analyze that also. So in that case, obviously we have to consider the outliers and we have to analyze that, but that is very rare. Most of the times we remove the outliers because as such it's not impacting overall, like it is not making any sense in my overall analysis, right? So that's the reason we remove the outliers. There are various ways to do that. We'll discuss about that in the future sessions. So here you can see that the examples, if age has a value 999 or -y, it's like wrong data, right? Which we have to remove. If 40% of the income data is missing, should I drop it or fill it, right? So 40% of one column, there are missing values. So as such, that is not making sense. And I may have to check with the business whether we can remove that entire column or shall I go ahead and do some this thing, right? Manipulation. 40% is a big number, so we may not normally manipulate. We remove that as such, but sometimes business may say that they need that column, so we have to manipulate that as well. How to manipulate and all, we'll discuss that. Again, the plots which we are using is again box plots, heat maps, all those plots we can create. Now here are different charts which we have, which we can basically create and we'll try to understand what's going on, right? So before I get into these charts, let's do one thing. Let's play around with one data. Whatever we have learned till now, we'll try to understand that by seeing one data set. Okay. So I'll launch Python instance. Don't worry about Python, what I'm doing in Python. We will have a detailed discussions on Python around 30 hours. So as such in this class, I'm not expecting that you will be understanding the entire code. My expectation is that you should understand the data. The charts which we are building, you should be able to understand that, right? That is the main thing which I want. So let me pick one data set. So let's say I'm taking this data. Right, so here you can see that the data is coming in. First of all, let me open this data in the Excel file as well. Here is the data set. So this is the data which I am using, right? Okay, so this is my data set which I am using. Now here, if you see the data set, we have a gender column, we have the loan ID, we have the married, we have the dependent, we have the education, self-employed, annual income of my customer, co-applicant incomes, which we have, loan amount, how much amount they want. your amount term, right? So basically for how many years or months, it's in the months, right? So how many months they want the loan to be. What is the credit history of my customer? What is the property area of my customer? And whether my customer got loan or not. Where 1 means customer got the loan and 0 means customer did not get the loan, right? So this is my data set. Now, whenever you are start analyzing the data, right, the biggest thing which we have to understand first is that what is the end goal, right? You have to find the end goal. As in this particular data set, my end goal is that the data is saying that whether my customer is getting loan or not, right? So here you can see that where 1 means customer is getting the loan, this customer got the loan, and 0 means this customer did not get the loan. So my end goal is what? My end goal is to know which feature is important to decide whether my customer will get loan or not. If you are a male, is it higher chances that you will get a loan? Or if you are a female, you have a higher chances to get a loan. If you are a married, do you have the higher chances of get a loan? Or if you are unmarried, you have a higher chances to get a loan, right? Same way, if you are having more dependents, will you get a will you have a higher chances to get a loan? Or if you have a lesser dependents, you have a higher chances of get a loan, right? Whether you are graduate, will you have a higher chances of get a loan? Or if you are not graduate, then you are having the higher chances of getting a loan. So I need to analyze all these columns considering a fact that which type of customer got the loan and which type of customer did not get the loan. So this column is very important for me for analysis. Whatever analysis I will do, I will keep in my mind to understand that, okay, I want to find out the important relevant features, that is important relevant column, which is deciding whether my customer will get loan or not. So in this example, that particular aim is in my mind to find out whether my customer will get loan or not, right? And with that aim, I will start analyzing the data. That means when we are trying to find out whether the customer will get loan or not, this loan status column will always be there for my analysis, right? Whatever charts I will create, this particular column will always be present in my chart, right? Because this is the main driving column, right? I need to find out what type of customers are getting loan and not. But now, as of now, what I will be doing is I will be just checking how many males or females are there. As of now, let's ignore the loan status column. I have only gender column, right? The rest of the columns you ignore. Whatever columns you have, just ignore that. Whatever columns you have, let's just ignore that. I only have this gender column. Now, what type of analysis I can do here? Only one column is there. So it is gonna be univariate analysis. Now, when I am doing a univariate analysis of the gender column, what type of information can I get from the data? How many males are there? How many females are there? Right? The only thing which I can get is I can count it. How many males are in my data set? How many females are in my data set? Right? So that is what I will do here in my Python instance. So let's come here. I want to create a chart here as of now, right? And my focus is only to help you understand how the chart looks like, right? What code I am writing, it's not you have to worry about because we have a separate discussion in detail once we'll start Python. So what I am doing and all those things, don't worry, right? Just keep calm. So here you can see the data set and the chart is coming in. This chart is known as count plot. The purpose of this chart is basically to find the count of the column which you are passing in. And here the column which I am passing is a gender. And clear cut from this chart, I can very well say that in my data set, we have more number of males as compared to females, right? I can clearly see that the bar which is coming for the male is a bit bigger bar, and the bar which is coming for the female is a smaller bar. So there are more males as compared to females, right? This type of analysis is my univariate analysis because I am analyzing only one individual feature, that is gender, in this particular data set, right? So that is the information. Same way, let's say I want to understand about the next column, that is your married column. Now what I want is I want to find out how many married people are there, or I can say how many married customers are there and how many unmarried customers are there, right? So I'll be taking this married column and I'll be passing here in place of gender. Now when I see this plot, I can clearly see that there are more number of married customers are there as compared to unmarried customers. Here you can see that yes is a bigger bar, no is a smaller bar, right? So from this analysis, we found out males are more than females and marrieds are more than unmarrieds, right? So that is the information we got till now. And here we are analyzing only one variable at a time, right? So we are actually doing the univariate analysis. Let's take another column, that is your dependents. So let's go and select this column again and put the dependents. And here you can see the chart again coming in, and I can see that majority of my customers are having zero dependents, right? So see, try to understand this. This was my data set. By just seeing this data set, will you able to tell me that there are more number of zero dependents or there are more number of males? We have around 600 records, right? We are having around 600 records. So by just seeing that, can I say that we have more females or more males or more married or more unmarried? I cannot say that, right? And that is the problem when you are having the data set, right? Data is very huge. As of now, we are dealing with 600 records. But when we are working with the industry, you will be dealing with the millions of records. With the huge amount of data set, if you want to get some insights as a human, by just seeing this entire text in front of your eyes, you will not able to answer. But yes, when you start creating the charts, human brain is designed in a way that it understands charts, colors, sizes, shapes, right? So as human brain is actually designed in a way that it understands these things. So that is the reason it is advisable to create the visuals, right? Now, just think about it. AI is coming in, everything is coming in, that is fine. Will I get a job? Will I not get a job? These questions are coming in as well. But just imagine that you are having lots and lots of data and you have to analyze that data. And for analyzing the data, you need to have some tools like Power BI, Tableau, and all those things, right? Python again. And you have to get the insights from the data by using those tools. Now, machine can generate Python codes. Machine can generate Python codes and create the charts. But for Tableau and Power BI, we need some human intervention as well, right? And obviously, data is growing. I want to find out the insights from the data. So, will I get a job? The answer is yes, obviously, right? Because company requires this type of people who are like aware of how to analyze the data, how to get the insights from the data, what are the important insights, and so on, right? By end of this class today, we'll understand from this data set that if a new customer comes in, let's set a goal here, right? For this class, the goal is that I want to know if a new customer comes in, whether he will get a loan or not, which feature is very important for me to decide that, right? We have a lot of features out here. If you go back to your data set, we have the gender column, married column, dependents, education, self-employed, applicant income, co-applicant income, loan amount term, credit history, property area, and based on that, whether customer will get loan or not. So by the end of this class, I want to find out the top, let's say, 3 features, which are really important for me to decide whether customer will get loan or not, right? As of now, we did not check that, but we will do all the analysis from our side and then we'll find it out whether which feature is very important. Okay. So that is the aim. With that aim, we are proceeding further. So we took the dependents also. Let's go and check for education as well. Do we have more graduates or do we have more not graduates, right? So let's go back and let's create the chart as well. As of now, we are taking all the categorical data. That's why the best chart which we have for categorical data in Python is count plot. So here I have education. And here you can see that we have more number of graduates as compared to not graduates, right? So the idea is basically when we are having, again, the idea is that we have more graduates and less not graduate people, right? So that is what we got from here. Now let's go to the self-employed, right? So let's go and let's check it out. Self-employed, E capital. So here you can see the chart coming in. From this chart, can you guys tell me whether we have more self-employed or less self-employed? Self-employed means yes, and no means those who are in the jobs, right? So do we have more businessmen as a customer or do we have more people with the jobs as a customer? What do you think? More people with the jobs, right? Perfect. So that is the insight which I can get from here. Now let's get into the next one. Income and all these are numerical columns. I'll take it in some time. Let's go to credit history, right? Credit history is like 0 and 1. So I'm considering it as a categorical data. And property area. Let's take these 2 columns, then we'll get into these few columns. So again, paste the code. Credit history. So here you can clear cut see that the customers I have are having credit history as 1. Majority of the customers which I have are having a credit history as 1. Credit history 1 means it's good. Credit history 0 means it's bad, right? So basically the idea is that majority of my customers are having credit history as 1. Few of the customers are having credit history as 0, right? So that is the information which I get from here. Let's add property area. So I have 3 different types of property area in my dataset. One is urban, second is rural, and the third one is semi-urban, right? So we have total 3 types of this thing, property areas. And now I can see that out of these 3 property areas, the majority of the customers are coming from semi-urban, right? Majority of my customers are coming from semi-urban and the less customers are coming from rural, right? So out of these 3 property areas, semi-urban is having more count, urban is having the second highest, and third one is your rural, right? So that is the information which I am getting in. Now let's go back to your this thing. I'll take one more column, which is your this thing, right? Loan amount term. Loan amount term is also, I am considering it as a categorical data only because if you see this data, right, it's actually a number. This is also a number only. But why I took it as a categorical? The reason is that if you see for property for credit history, we have only two values, 0 and 1, right? So 0 means bad, 1 means good. That's why I am considering it as a categorical data, because 1 means good, 0 means bad. Why I am considering loan amount term as a categorical data? Because if you see the term, right, it's a fixed term. The term which you can see here is a fixed term. 12 months, that is 1 year. 36 months, that is 3 years. 60 months, that is 5 years. 84 months, that is 7 years, and so on and so forth, right? So we have the 1 year loan, 3 year loan, 5 year loan, 7 year loan, 10 year loan, 15 year loan, 20 year loan, 25 year loan, 30 year loan, and 40 year loan, right? So it's a fixed set of numbers. So that's why I am considering it as a categorical data, and I will be passing this loan amount term in my chart. And from here, what I am understanding is that majority of my customers are opting for 360 months of loan. When you are taking any loan, you have to give the tenure that I want the loan for these many years. So here also customers are giving the tenure that, okay, I will be going with 30 years of loan. 360 months is what? 30 years, right? So I want to go with 30 years of loan. So majority of my customers are looking for 30 years of loan, right? That means if a new customer comes in and he is asking for taking a loan, chances are higher that he may ask for 30 years. That is 360 months. So here is the majority, which I have 360. Apart from that, 180 months is the second highest, and then rest are almost very negligible, right? So this is about all the categorical information which we analyzed. And again, I did only univariate analysis. I was in every chart, I was using only one variable, right? I was using only one variable. I was using only one variable. I was using only one variable, and so on, so forth. And all are categorical variables, right? I analyzed only one variable, that too categorical. Now I will be analyzing again one variable, but that will be numerical, right? Now I will be analyzing a numerical variable. And what all numerical variables we have in our data set? Applicant income, co-applicant income, and loan amount, right? These are the three numerical columns which I have in our data set. That is applicant, co-applicant, and loan amount. So let's analyze that. The chart which I am going to create, if you go back to your PPT, here you can see that, right? When I'm talking about the univariate analysis, here you can see count plot we just gone through. When I was dealing with the categorical feature, I was using count plot. When I want to deal with the numerical feature, I can either use the histogram or I will use the box plot, right? So let's use histogram for now. So let's go ahead and write sns dot hist plot data is equal to df, x-axis is my loan applicant income, right? Applicant income. And here you can see that we got this plot, right? We got this plot. And here, what type of chart it looks like? I see straight away, this chart is like a right skewed chart. Majority of the values are here, but there are some outliers here as well, right? So this is like my right skewed chart. And when it is a right skewed chart, the chances are very higher that mean will be at the higher side as per our understanding, right? Let's go and check it out. It may not be very higher side because outliers are very rare in number, but it should be bit of a higher side. Let's go and check it out. Applicant income, mean is 5.4, and this is C, clear cut. My median is around 3,800 and my mean is around 5,400 for applicant income, right? So if you see here, my mean is around here, and sorry, my median is around here and my mean is around here. Around 3000 is my median and my mean is around 5000. It's not on the same lines, right? That means this is right skewed. The mean is at the higher side. That is what I was expecting, and that is what happening here as well. Let's go and check for the other numerical column. That is your, okay. Let's go and first check the numbers out here, right? My mean is 1621 and my median is 1188. What type of chart do you think will be coming in? What type of chart will be coming in? Left skewed, right skewed, or normal? What do you think? Will the chart be something like this, or will be something like this, or will be something like this? Option number one, option number two, option number three. What do you think? Perfect. Option number one, right? So let's go and check it out. This is my column. You can see bit of outliers. Perfect. Same way, let's go to the third feature. That is your loan amount. Loan amount is also at bit of a higher side as compared to the median, right? Although it's not very far, but yes, because the numbers are also very small. So 20 is also a big number. The difference is 20. So that is also a decent number, right? So it should also be a right skewed. Let's go and check it out. You can see bit of outlier is there. So that is looking perfectly fine. As per our understanding of mean median mode, without creating the chart, I will get the understanding how the data should be, right? So now till this point, what we did was we analyzed univariate type of analysis. And I took all the features. I did not miss any feature. All the features I took care of. I took gender, married, dependent, education, self-employed, applicant, co-applicant, loan amount, term, credit history, and property area. Let's take loan status also. I just wanted to know how many people are getting the loan, how many people are not getting the loan. It's also one type of analysis, right? So let's go and check it out. I will use here count plot because 0 means no, 1 means yes. So SNS dot count plot. Data is equal to DF. X-axis is my loan status. So here you can see that majority of my customers are getting the loan, right? Because 1 is getting the loan, 0 means not getting the loan. So that is pretty much okay. One interesting insight from here I can give you. Can I say, all of you, can I say that people getting the loan and people not getting the loan, the ratio is 2 is to 1? If two people are getting the loan, one person is not getting the loan. Can I say that? Right? Because if you see roughly 400 people are getting the loan and 200 people are not getting the loan. That means total 600 people came in. Out of 600 people, 400 people got the loan and 200 people did not get the loan. And when I take the ratio, that is nothing but 2 is to 1. Right? So that is the ratio which I am getting here. Till this point, are you guys clear, all of you, what we discussed? All right. Now let's get into the bivariate analysis. Now bivariate can be what? Bivariate can be two categorical. Bivariate can be one categorical, one numerical. Bivariate can be two numericals, right? As of now, again, I am not analyzing entire story, as we have to conclude this particular class with some conclusion, proper conclusion, right? So what I will be doing is, I will be making sure that in every analysis, your loan status column should be there, right? Because what is my aim? My aim is to know, do we have any feature which is basically deciding whether my customer will get loan or not, right? So basically the idea is that I want to focus on loan status in my all the analysis, all the charts, which now I am going to build. Okay. That is the idea. So that means I fixed one column, that is loan status. And what type of that column is? It is a categorical column, because 0 means no, 1 means yes. So one categorical column I already fixed, and I am saying that I will take this particular column in all my charts, right? Why I am doing that? Because we have to conclude this class with one proper conclusion, that if a new customer comes in, on what basis he will get a loan, right? So that is what we need to find out. That is the end goal which we have. So what I'll be doing is, I'll be creating some count plot first, right? And what did I tell you at the time of the analysis and at the time of the PPT as well? We are using count plot for the univariate analysis. But what are we doing? We are doing the bivariate analysis. In bivariate analysis, did I put any count plot? No, I did not. Right? I had to put that. Right. So basically, the idea is that I can use count plot for the bivariate analysis as well. Now, question arises, how? So let's do that. I will create my plot, sns.count plot. Data is my df. X-axis, let's say I want gender. And here I cannot pass any y-axis, because count plot cannot take any y-axis. But count plot take colors. So there is one option called hue. Again, all those things we are going to discuss in Python, so don't worry about that. And here I will be adding loan status. So basically I am going to create two charts, two bar only. But this time that two bars, the gender bar which we had, right? Here is my gender bar, male, female. So you are going to create two bars only. But now male bar will be further broken down into two. And female bar will also be further broken down into two. The two bar will be one male, those who are getting the loan, female, those who are getting the loan, same way male, those who are not getting the loan, and female, those who are not getting the loan, right? So basically when I am adding the color in this particular chart based on the loan status, your gender will be broken down by loan status. Male getting the loan, male not getting the loan, female getting the loan, female not getting the loan. And now here you can see the chart coming in, where I have the four different bars coming in, two coming in the blue color. Blue means 0. That means customer not getting the loan. Orange means 1. That means customer getting the loan, right? So now by seeing this chart, can you guys tell me, if you are a male, you have a higher chance to get a loan? If you are a female, you are having the higher chance to get a loan? Or if you are male or female, I don't care. What do you think? Which option is correct? Male with higher chances, female with higher chances, or gender does not matter? Option number 1, if you are a male, higher chances. Option number 2, if you are a female, higher chances. Option number 3, gender does not matter. All of you guys are saying male, few of them are saying does not matter. Okay. The correct answer is gender does not matter. Right? Now question arises why? I just told you in few minutes back about the ratio concept, right? Focus on the ratio here. How many males got the loan? Roughly 350, or let's say roughly, yeah, 350 or something, right? Let's make it 350, right? So 350 males got the loan. How many males did not get the loan? 150. What is the ratio? 2 point something. 350 by 150. 2.3. 2.3 is to 1, right? Roughly. Round it off to 2 is to 1. Let's come to females. Roughly 50 females did not get the loan. थोड़ा ऊपर कर दिया मैंने, but 50 मान के चलते हैं, right? So 50 females did not get the loan. 100 females got the loan. That is also 2 is to 1, roughly, right? Male is bit higher, but almost the same ratio, right? It's not very significant. I cannot say that, okay, you are a male, you will definitely get the loan. No, it's not like that, right? So ratios are almost on the same lines. That means the selection of a loan is to the rejection of a loan for a male is almost on the same lines with the selection of a loan is to rejection of a loan for a female. That's why from this chart, I can say that it's not very significant. If you are a male or if you're a female, as such, it does not matter. Very clearly, it's not matter. Right? It's not very significant that male होगा तो पक्का लोन मिलेगा, ऐसा लग नहीं रहा है. Are you guys getting this, all of you? So that's why gender does not matter. Now let's take another feature then. Rest of the feature you can try from your side. You can use any other tool if you have any knowledge. Python you may not be aware of. You can use Excel and all those things. Or you can manually check it out, right? Till the time we are not expert in any of the tools. So let me add property area. From the property area, can you conclude something? By seeing the chart, can you conclude something about property area? All right. So can I clearly say that semi-urban is having bit of a higher chances to get a loan, right? As compared to other regions, other property area. That is clear cut coming in, right? We have less rejections out here. So it is not very significant, but yes, it is decent, right? If property area is semi-urban, I can say yes, chances are higher that you will get a loan. Let me come to the most important feature. That is credit history. By seeing this plot, you will get the real understanding of what it means, right? If you are having credit history as 0, almost negligible loan is approved. If your credit history is 1, your approval is on the higher side. When your credit history is 0, your rejection is higher as compared to approval. So clear cut, this feature is very important. If a new customer comes in and his credit history is 0, he will not get the loan. The chances are higher he will not get the loan. If a customer comes in with the credit history as 1, the chances are higher that he will get the loan. Are you guys understanding this plot, all of you? Straightforward, right? All right. So as of now, I was analyzing two variables, and in that two variables, I was having one variable as a categorical variable, and second variable is also a categorical variable, right? Credit history was a categorical variable 0, 1, and loan status is also categorical 0, 1. So here you can see that I am creating a count plot with two categorical and categorical features. Now let me take one categorical and numerical. So we got the idea that which feature is important. Credit history is important. Semi-urban is also a bit of important. Rest all are okayish, right? Or not important. So let's divert from that. The aim was to understand which features are important. We got two features. So rest of the features, I know almost are not important. So you can play around with that from your side. Now I'll be doing what? I'll be taking one categorical and one numerical. Till this point of time, I did bivariate, but I was having two categoricals. But now I will be taking one categorical and one numerical. For example, let's say I am taking this loan status. Loan status is a categorical, right? And let's say I am taking applicant income. Okay. So loan status is a categorical column and applicant income is a numerical column. The plot which I will be using is bar plot, right? So SNS dot bar plot data is equal to df. X-axis is your loan status and y-axis is your. Now when we are creating bar plot, we have to give x and y both. Again, it's a Python part. You can skip this for now. Applicant income. So now when I run this, here you can see that I am getting some chart like this. Applicant income for people who are not getting the loan and people who are getting the loan are same. That means what? Applicant income is as such not important. Why? Because this is again, this income which you can see is an average income, right? If you go back to the documentation, I'm using basically Seaborn. This is one of the packages which I'm using. We'll discuss more in detail about Python, so please don't worry about that. But I just wanted to show you that this is nothing but average. You can see here I was using Seaborn. So there is one official website for Seaborn. And if I go to bar plot, here is the official documentation. You can see by default, it is taking the average. Estimator is equal to mean, right? If you change this average to sum, it will give me the sum. You will see some in the documentation estimator. Yeah. Here you can pass sum also. Suppose let's say I'm passing here. Let's go down. Suppose I'm changing this estimator is equal to sum. It is going to give me the sum, right? It's a sum of salary. It's a sum of salary. This is not gonna make sense. समझने का ट्राई करो. मेरे पास अगर तुम वापस उस डेटा पे जाते हो कि कितने लोगों को लोन मिला, कितने लोगों को लोन नहीं मिला, यहाँ देखो 1 वाले बहुत ज्यादा हैं और 0 वाले कम हैं. तो तुम 1 वालों की सबकी सैलरी सम कर रहे हो और तुम 0 वाले की सबकी सैलरी कम सम कर रहे हो. सो ऑब्वियसली 1 वाले बहुत ज्यादा हैं, तो अगर मैं सबकी सैलरी सम करूंगा तो ये भी ज्यादा ही होगा, सैलरी भी ज्यादा होगी, और यहाँ पे 0 वाले की सैलरी कम होगी. So the same thing you can see here as well, right? the salary for the people who are getting the loan, the sum of the salary is very high, which is expected because we are summing up the salaries for all the customers who got the loan. And this is the sum of salaries for all the customers who did not get the loan. But this is not a correct measure to check. The correct measure is average salary. Those guys who got the loan, what was their average salary? Those guys who did not get the loan, what was their average salary? If there's a big difference in that, then I can say that yes, salary is an important factor. Suppose my average salary for those guys who are getting the loan is very high as compared to the average salary of those guys who are not getting the loan. Then I can say that average salary, or I can say salary, is an important feature because the average salary of the guys getting the loan is higher as compared to the customers who did not get the loan. But that is not happening here, right? Here it is almost the same. That means your salary is not gonna make any sense to decide whether you get a loan or not. Is that making sense, all of you, what I'm telling here? Right? So let's play around with this for the loan status as well, and sorry, loan amount as well, and co-applicant income as well, right? तो जाके check करते हैं. So co-applicant income, control V. Those guys who did not get the loan, right? Their co-applicant income was higher, right? जिन बंदों को लोन नहीं मिला उनका co-applicant income हायर था. तो ये तो थोड़ा उल्टा हो गया कि जिस बंदे का co-applicant income हायर होगा उसको चांस है लोन नहीं मिलने के. इतना सिग्निफिकेंट नहीं है, जस्ट अ जोक, राइट? आई वाज जस्ट जोकिंग. It's not very significant. But yes, those guys who did not get the loan, their co-applicant income was bit higher. It's not very significantly higher. Okay. So that is fine. Let's go to loan amount now. ऐसा तो नहीं है कि तुम ज्यादा लोन अमाउंट मांग रहे हो तुम रिजेक्ट हो रहे हो. ऐसा हो सकता है, राइट, कि तुम ज्यादा लोन अमाउंट मांग रहे हो इसलिए मैं रिजेक्ट कर रहा हूं. तो वो चेक कर लेते हैं. So loan amount. No, it's not like that, right? So basically the average loan amount which you are asking who are getting the loan is almost on the same lines of those who are not getting the loan. तो ऐसा नहीं हो रहा है कि तुम ज्यादा लोन मांग रहे हो इसलिए तुमको मैं रिजेक्ट कर रहा हूं. It's nothing like that, right? It's not happening like that. So that is also fine. So as such, these numerical features are also not looking that great to me, right? We analyzed all the features and as such we don't see any interesting patterns out here. Only the credit history was looking good and bit of a property area, right? So here, what type of analysis I did? I was doing bivariate analysis. Loan status, co-applicant income, right? So it's a bivariate analysis. That is categorical and categorical. So I have shown you categorical and numerical, right? I have shown you categorical and categorical. I have shown you categorical and numerical. Now I will show you numerical and numerical. So if I come to my data set, I have, let's say, applicant income and co-applicant income. Both are numerical. And the plot which we normally use is a scatter plot. Data is equal to df. X-axis is equal to your applicant income. Y-axis is your income, right? So here you can see that we got the plot. And as such, I cannot see any pattern here. The only thing which I can see is that all the values are at the lower side. Few values are at the higher side for the applicant income and few values are at the higher side at the co-applicant income as well. It's a plot between the applicant and co-applicant, right? So it's an applicant and co-applicant. So I see that few of the customers who are having higher co-applicant income, few of the customers who are having higher applicant income, but majority of the customers are at this range only, right? Between, let's say, 20,000 to 10,000. So in this, I don't see any pattern as such, right? I don't see anything. All are cluttered, right? Let me add loan status as well. Let me add loan status in color. Loan, so hue is equal to loan status. And now when you see the plot, you can see that all are cluttered only, right? There is an overlap between the green, oranges and blues, right? There is an overlap between oranges and blues. That means there is no clear-cut difference. All are cluttered. I'll explain this in some time. But as such, I am not getting any information. And one more thing I want to highlight here is that one numerical I took, second numerical I took, and one categorical also I took. This is my multivariate analysis because I am taking 3 or more than 3 variables, right? So when I introduced the loan status in the color, automatically from bivariate, it became multivariate. Now, why I am saying that this is not making any sense? Let's try to understand this. I am creating this plot. These are, let's say, orange means ones, right? So let's say these are ones, orange, and these are blues. Okay. And this is my applicant income. This is my co-applicant income. If my plot would be like this, अगर मेरा plot ऐसा होता, तो ये प्लॉट बहुत ही ज्यादा अच्छा प्लॉट होता. क्यों अच्छा प्लॉट होता? बिकॉज यहां पे मैं क्लियर कट बोल सकता हूं कि जिनका एप्लीकेंट इनकम ज्यादा है एंड जिनका तुम्हारा को एप्लीकेंट इनकम भी ज्यादा है, उनको लोन मिल रहा है. They are getting the loan. Orange dots, right? So those guys who are having the higher applicant income and those guys who are having the higher co-applicant income, they are getting the loan. And those guys who are having lower applicant income and those guys who are having lower co-applicant income as well, they are not getting the loan. That's why this plot is a beautiful plot and making a lot of sense. But am I getting something like this, all of you? Am I getting this chart like this? The answer is no, right? Here all cluttered. They have the low applicant, co-applicant, and all are in blues and oranges, right? I cannot have a clear-cut segregation. Here I have a clear-cut segregation. कि ऊपर वाले सारे लोन मिल रहा है, नीचे वाले सारे लोन नहीं मिल रहा है. But here I cannot see that type of segregation. And that is why I told you that this is not making any sense. Okay. I hope this entire discussion which we had made sense a bit. Any doubts? Let me know. Till this point. All good? Okay. So let's quickly go through this PPT where I stopped, right? Then we'll end the session. So bar chart, now we know. Bar chart is basically when we have the one category and one number, right? Revenue versus region is the example here. There also we created the bar chart here. Loan status versus the applicant income. Loan status was the categorical column. Applicant income is the numerical column. So when we have the one categorical and one numerical, in that case, we prefer to create the bar chart. Comparing values across discrete groups, right? Discrete is like categorical type of groups. Second is pie chart. Pie chart is also used for the same scenario. Revenue is a number and region is a category. So pie chart also we are using when we are dealing with the one categorical column and one numerical column. Okay. So that is my pie chart. Scatter plot we discussed. When we are having two numbers, we create scatter plot. Box plot, which we had a brief discussion, we'll talk about that maybe more in detail. But box plot is basically nothing but where we'll discuss in few sessions, but in Python also we are going to discuss this. So basically this is the box plot, which is helping me understand about the distribution. This black line in between is my median. These boxes are my 25th and 75th percentile. All those things we had a discussion. Here, this is my outliers, right? So that is again one plot which you can use with category and number or only number as well. We can use it for univariate analysis as well, only number, right? So box plot can be used for univariate or bivariate. Univariate only number or bivariate one number and one category. Because यहाँ देख लो, यहाँ रीजन एक कैटेगरी है, रेवेन्यू एक नंबर है, राइट? सो हर बॉक्स प्लॉट अलग अलग रीजन को डिनोट कर रहा है और रेवेन्यू मेरा नंबर है, राइट? सो या तो तुम ओवरऑल रेवेन्यू पे बना दो बॉक्स प्लॉट, रीजन को डालो ही मत, तो वन वेरिएबल हो जाएगा यूनिवेरिएट, या फिर तुम रीजन के साथ लेके आ जाओ, तो रीजन प्लस रेवेन्यू विल बिकम बाइवेरिएट. Line chart is basically we are using when we have time in my x-axis. For example, I want to find out the revenue by month. How is the revenue going on? So whenever the time is coming into picture, when you want to create a chart over the period of time, in that case, we are using the line chart, right? Histogram we discussed as well. Only number is there, revenue. Revenue का frequency बता रहा है, right? I can clear cut say that majority of the revenue is falling somewhere here. Here I have some values, here I have some values, but majority is lying somewhere here, right? So that is my histogram, only number. That is univariate analysis. Pair plot is again a collection of scatter plot, right? So here you can see that I have ad spend versus profit, revenue versus profit, ad spend versus revenue, right? Revenue versus ad spend, profit versus revenue. Basically, it's like a symmetrical chart. Ad spend and profit, revenue and revenue and profit, and same way here also. ये तीन देख लो, ad spend, revenue, revenue, profit, profit. So basically this chart which you can see is exactly same as these charts which you can see, right? ये symmetrical chart है. And this diagonal is a histogram. Ad spend versus ad spend, इसका histogram दिखा रहा है. Revenue versus revenue, इसका histogram दिखा रहा है. Profit versus profit, उसका histogram दिखा रहा है. It's just showing me how the profit is distributed, how the revenue is distributed, how the ad spend is distributed. And this chart is exactly same as these three charts. And it is what? It is a multivariate analysis. Because we have three variables, right? It's a multivariate analysis. Concept is the same. Scatter plot, how we understand, the same way we understand this also. It's a scatter plot only, but with more number of features. Okay. So that is pair plot. We'll see again once we'll learn Python. At that time, we'll discuss. One more plot which we have is joint plot. Joint plot is also a scatter plot. It is showing me the histogram as well. For example, let's say this is my ad spend and this is my revenue. So this is the histogram for revenue. This is the histogram for your ad spend. And this is the scatter plot of ad spend and revenue, right? So it's showing me the scatter plot plus the histogram of individual features. Histogram is helping me to understand the distribution, right? So this is the distribution of ad spend. This is the distribution of revenue. Okay. Okay. Next is the heat map. Now this heat map I will be discussing in the tomorrow's class, because for this we should have the understanding of correlations, right? Tomorrow or maybe the next class we'll discuss. I think tomorrow only we'll discuss that. Okay. Because tomorrow's topic is correlation only. We'll do some of the mathematics and we'll try to understand. So I'll stop here, right? I hope you got a bit of understanding what the EDAs are, right? Any questions you guys have, let me know. Whatever we are discussing, you should be very much thorough with all these things because all these things are very much important for you as a data analyst. Any doubts, go through the recordings, ask me in the next class. But you should be very much ready with the understanding of data before we start with the practical tools like SQL and Tableau or Power BI or Python, right? Before that, you should have the understanding of data. That's why we are discussing that so that it will not be very overwhelming for you guys just by seeing the data. ये सब क्या हो रहा है, right? That's why we are discussing all these things. So go through the recordings. Any doubts, ask me in the next class. And yeah, we'll connect at 9:30 tomorrow. Okay. All right. Thanks for your time. We'll see you in the next session.